So here we go. It says the figure shows the graph of function f. The 0 and extrema for f are labeled, and the point of inflection of the graph of f is labeled. Let A, B, C, D, and E represent the x-coordinates at these points. Okay, so for our very first warm-up, and we're doing these to kind of spiral back in the stuff from last semester, right? Because we got a big old exam coming up. All right, so for A, let's see who my volunteer is going to be. Yamalex. On what intervals is f increasing at an increasing rate? What do you think? From D to E. Do y'all agree with that? So that would be this right here, okay? F is definitely increasing, right? And then the rate is increasing. How do we know that? It is concave up. Very good, the concavity. So having your fun chart written down could be very helpful. It's something we want, right? So that can help you with that. Thank you very much, Yamalex. All right, my next volunteer for B, Bray. C to D. Do y'all agree with C to D? Increasing at a decreasing rate. Do y'all agree with that? From C to D, is the function increasing? No, function's decreasing, right? Where's the function increasing at a decreasing rate? Bray, you want to try again? A to B. Okay, so let's try A to B. It's okay. So A to B, are we increasing? Yes, and the rate is decreasing because the function is concave down. Very good. Okay, we good on that? All right, perfect. Ethan, what about B? Oh, I'm sorry. Were you answering this one? I just realized I said B, but I did this one. I don't know. Okay, I'm so sorry. So it is decreasing at an increase. You were right about B. Good job. I said B and I went to C. I wasn't looking. So from C to D, which is what Bray said, which is she was answering B because I said B, it is C to D. All right, there you go. Sorry about that. All right, Ethan, you're going to do the last one for me then. Decreasing at a decreasing rate. What's that? B to C. Okay, very good. Decreasing and concave down. All right, any questions about that? That was my fault there. Sorry about that. All right, now let's look at this next one. Given this function, determine the average rate of change of h over this interval. What does average rate of change mean? Slope. Good Lord in heaven. And I like to rewrite this as like this, okay? So the first thing you should do is write down, this is h of x. So we're going to have h of 2 minus h of negative 5 over 2 minus a negative 5. Right? That's step one. I don't even have to worry about whether I have an equation, a table, a graph, or anything yet. But because I don't have a table or a graph, I have to actually calculate these. So I need to find h of 2. H of 2 would be 2 squared minus 2 times 2 minus 2, which is going to be 4 minus 2, which is negative 2. Then I got to find h of negative 5. And that is negative 5 squared minus 2 times negative 5 minus 2. So that is 25 plus 10 minus 2, 33. Okay, do y'all agree with those? This is slope. This is 7th grade work, literally. And so that is negative 2 minus 33 over 7 is negative 35 over 7, negative 5. Slope. Okay. What questions we got? Anything? All right, so make sure your name is on the front of your booklet. On your table, you have these black boxes. The purple hanging folder is for your class. There should be a folder in there with your name on it. This goes in that folder. Along with that, we'll have other things when we're reviewing that can't leave the classroom. We're going to leave them in these folders. So just get, and I don't want you to have to keep up with your warm-up books, okay? We all good on those? All right, good deal. And then grab your notes for today. All right. And this is going on page 83 when we are done. Page 82 is just your title page for the 5th 6 weeks. I don't know if that I had put that on the calendar. I'll remind you of that when you're taping these in. We are doing, so 3.2 comes in 2 parts, but we're doing both parts together because we've really already talked about most of this because I front loaded you with the unit circle stuff. So we're just going to kind of go through this pretty quickly. All right, so in this course, we approach angles in a way that's different than what you've seen in the past. And it's a generalized method to allow us to view them through a periodic lens. We talked about periodic functions last week, right? You can just kind of stamp them along the way, they just repeat. And so we need a few clear definitions. We've already talked about the fact that we can have angles in the coordinate plane. Yes, angles are able to float around anywhere, but we're really only concerned with them when they are in standard position. That means that its vertex is at the origin and one ray is on the positive x-axis. So center's at the origin, here's one ray on the positive x-axis. The other ray is the one that spins around and actually makes our angle. That is called the terminal ray. Okay. The first one actually has a name as well. This one is called the initial ray. Or the initial side, you could say, either way, but okay. So we learned about that and how they rotate and all that good kind of stuff. And then made our unit circle and talked about trig. We're going to start off talking about circles, but not necessarily a unit circle. Okay. The radius could be anything. We're going to look at sine, cosine, and tangent. And so when you look at this circle here, we have point P, right? Point P, we have an x value. That x value there, I swear I changed my color. What is wrong with this? My x value, we would consider that it is a horizontal item, right? So horizontal displacement, and I will explain that word more in just a minute. Horizontal displacement, because your x makes you go left and right. Y makes you go up and down. So this is our vertical displacement. Okay, horizontal displacement, vertical displacement. That's your x and your y. And then your r, that's your radius. But that is just the distance between origin and the point P. Okay. It's just the straight distance there, where x is how much we go left or right, y is how much we go up or down. Okay. And there's a difference between distance and displacement. Any of my physics people able to explain that to me? What's the difference between distance and displacement?
No, like displacement, like you walk here and you end up in the same spot.
So if I walked here, if I started here, it went all the way around the circle. All the way around the circle is my distance, but my displacement would be 0 because I ended right back up at the same spot, right? One of them can be positive. One of them gives you direction also, right? Your direction is positive or negative. Distance is just always positive. Okay, that's another difference there. So good. All right. So for our sine, we know that sine goes with y. That's something we should already know. And it is the ratio of the vertical displacement. So that could be positive or negative, right? Vertical displacement from P and the x-axis to the distance, which can only be positive, between the origin and point P. So the radius is a distance. So radius is always positive. X and y are displacement. So we've said for a while that sine of theta is equal to y, but I also reminded you a few times it's technically y over r. We got to just use y because it was a unit circle though, right? And then cosine, ratio of the horizontal displacement, again, positive or negative, to the distance, which is just positive. And your cosine is x over r. because cosine goes with x. And then we know that tangent is y over x, or sine over cosine. Again, we've already talked about that, but here's the new piece to this. Tangent of theta is the slope of the terminal ray. This is huge. You have to make sure that you understand that. It is also the ratio of the vertical displacement, which can be positive or negative, to the horizontal displacement, which could be positive or negative. But think about the fact that over here, I've got this ray, and it can go, like it's part of a line, right? The slope of this line, is that positive or negative? The green one, positive. So it's positive, but guess what? Tangent's positive in the first and third quadrants. If I had a line going like this, the slope is negative, and tangent is negative in the second and fourth. It is literally the slope. It's the change in y over the change in x, and we have y over x. So it's just the slope of that line. That's all it is. Okay, we okay with all that? All right, good deal. Flip that over. Slope, tangent is slope, tangent is slope. Okay. So the figure shows a circle centered at the origin with an angle measure of theta in standard position. The terminal ray of the angle intersects at point P. So they have theta and P already up there for me. And then it tells me these are my coordinates. You want to label that and pay attention to that, even though it might seem simple and ridiculous. And I'm going to tell you why that's so important when we get to another question. Which of the following is true about the cosine of theta? Okay, so nothing's weird here. It's not like they switched x and y or whatever. And I know that cosine goes with x or y. Which one? X. Which means this y over 3 and this y over x, those two don't make any sense at all. So I can eliminate b and c automatically. And then cosine, would it be x over 3? And where is 3 coming from? It's the radius. How do we know that the radius is 3? It says right here. It doesn't actually say the radius is 3 anywhere, which sometimes it will, but it has it up. I mean, it kind of does, it just not in words. It's right there. That's how we would know for sure. So x, is it x over r or r over x? X over r, so my answer is A. I didn't have to worry about the rest of the words, but let's read the words because you can't always answer all the questions like that, right? But it says the ratio of the horizontal displacement from the y-axis to the distance between the origin and point P. So that's your horizontal displacement, that's your x over your r. Okay. Everybody okay with that? We good? All right, next question. This says the figure shows a circle with radius 5 centered at the origin, angle measure of theta in standard position, terminal ray of the angle intersects the circle at point P. So P is right there. That means that this is my angle, and it went around like this, okay? There at point P. So what is the ordered pair for point P? What would the x value have to be? 3, negative 4, yes. Because they gave us 3, 4 up there. And it's showing you that it's just a reflection down there. Okay, so I know that sine is y over r. The y value here is a negative 4. What is r? 5. We know that for a couple of reasons. We know that because it says it right here, also because it's labeled right here. But if neither one of those things were there, we could still figure it out by doing Pythagorean theorem, right? So there's plenty of information there. Cosine we know is x over r. So that's going to be 3 over 5, right? Tangent we know is y over x. So that's just negative 4 over 3. Okay, has nothing to do with my unit circle values. I don't know what the angle measure is, and I don't really care at this point. Everybody okay with all that? Not too bad. All right, good. Grab your other sheet of paper. This is also going on 83. And so this says, the figure shows a circle with radius r, centered at the origin with an angle measure of theta in standard position. the terminal ray of the angle intersects the circle at point P. The coordinates of P are x, y. Okay, that's already on there for me. That's good. Points Q, R, and S are the result of reflecting point P across the y-axis, the origin, and the x-axis respectively. So that's just exactly like what we did when we built our unit circle. It reflects down, it reflects over. So if this is x, y, I know this has to be negative x, y, right? This would be negative x, negative y. And this would be x, negative y, right? Easy enough? Because of all those reflections that we've already talked about. So then it asks me for these ordered pairs. Well, we just found them. So that's negative x, y, negative x, negative y, and x, negative y. And then we're going to pause there for a second. And we're going to write extra over here because we're going to draw a little something extra, but we're not actually using this to solve anything right now. I just want to make a point about why I was telling you you need to make sure you label that xy when it says that. Because let's say that this ordered pair here is negative 7, 2. Okay. If that is the case, what is the value of x? It's 7. It's not negative 7, right? This says negative x, so that means x has to be a positive 7. You with me on that? So you have to be careful about how you're reading that. So let's say that I gave you a point and I said, okay, this point A, this point is xy, which is totally fine. But that would just mean my x would be a negative value, my y would be a positive value. Does that make sense to you? So then if I asked for a point down here when it reflects, this point here then would be x, negative y. Because it's based on this one, not based on what happens in the third quadrant. It's just based on whatever's going on in that question. Now, most of what you would see is probably going to be done like this, but I have seen questions like this. So you have to pay attention to what it is and don't just zip through it. We good on that? Okay, just make sure you're thinking about what you're seeing and not just assuming anything. Okay, but again, that's just extra. I'm not actually using that down here. It was just an example for you. Okay, so now this says, find the sine of the angle whose terminal ray intersects at point S. So we're going to find the sine of alpha because we've already used theta. Sine of alpha, and that's at S. And I know sine is the y value over the radius. The y value at S is negative y, and r is r. Cosine, let's do cosine of beta. It's like a bubbly capital B with a little tail. I know that cosine is the x value over the r. So at Q, the x value is negative. So this is going to be negative x over r. Everybody okay with where all that stuff's coming from? Just kind of assume we've already kind of talked about this stuff a little bit. All right, so now we're going to use gamma. We don't have to write gamma a lot, and my gamma is terrible, so that's one of the reasons I'm doing it, to show you it doesn't have to be perfect. I'm going to draw it, and then I'm going to tell you kind of how I think about it. To me, gamma is like if a y and a lowercase r had a baby. You see how it's like a lowercase r, but it's like stretched and looks a little weird? Or like a little tree thing? That's kind of gamma. It's the best I can do with gamma. Doesn't hurt us to try new things, even if we're not good at it. All right, so then that's at point R. I know that negative, what goes on top? No. Negative y over negative x, which just gives me y over x. Okay. Because in the third quadrant there, tangent is positive. Yes? All right, any questions at all? Awesome. All right, so this here says, let theta be an angle in standard position whose terminal ray coincides with this line in quadrant 2. Find the following values. Well, just by what they gave us and me just looking at that, I can tell you one of those 3 values. Which one can you tell me and just know automatically? Tangent. Why? Because it is the slope. Very good. Tangent is the slope, so tangent of theta is -3. Okay, it's the slope of that line. And I'm in quadrant 2, and that makes a difference. So here, let's kind of draw this so we have something to go with here. We have our line goes through like this, right? But I'm in quadrant, I could either be in quadrant 2 or quadrant 4. It's telling me quadrant 2. And the reason that is important is because then I know that this is where my triangle is. And then I'm going to draw my triangle bigger out here. This is where my theta is. And I've got to be able to figure some stuff out. Well, I know that tangent is y over x, and that 3 would be 3 over 1. And one of those two values is negative, not both of them. Since I am in the second quadrant, what is negative, the 3 or the 1? The 1. So that one's negative. You see all those decisions you got to make? Tangent is y over x, and because I'm in the second quadrant, that is the one that is negative. That is the radius. That's why your quadrant makes a difference, okay? Then I don't know the radius. How am I going to find it? How do I find it? Pythagorean theorem. 3 squared plus negative 1 squared equals r squared. 9 plus 1 equals r squared. So r is the square root of 10. It's technically plus or minus, but the radius is always positive, so it's just the square root of 10. Okay, Pythagorean theorem. All right, sine y, which is 3, over r, which is the square root of 10. Am I allowed to leave it like that? Nope. So this has to become 3 square root of 10 over 10. Cosine is x over r, so that's negative 1 over the square root of 10. Once again, I got to square it in the denominator, so that's negative square root of 10 over 10. Any questions at all? All right, y'all go ahead and tape those in. I'm going to give you the second set of notes. I killed a lot of trees today. I'm actually going to give you the second set of notes and the assignment all at once so you have time to tape. Need to retest if you actually did your assignments beforehand. All right, this is going on page 84 when we are done. Make sure you have 1 up 2. I passed them all out. Hopefully you shuffled them out correctly. Okay, this is going to go quickly too because this is stuff we've already talked about, but doesn't hurt to see it again. So reminder, we got an angle in standard position, we got a terminal ray, all that good kind of stuff. Here's our angle. This we could call theta. You know all that stuff. Here's something else you already know. That positive and negative angle measures indicate the direction of the rotation. And we know that positive angles go counterclockwise, negative angles go clockwise, right? That's all old news. And since we are using the coordinate plane to define angles, we consider the angles to have periodic behavior. Okay, angles in standard position that share a terminal ray differ by an integer number of revolutions. Those are your coterminal angles. Remember we talked about going out, if we went out to the track and we all started and ended at the same spot, it doesn't mean we all ran at the exact same amount of laps, right? I mean, I could be walking, you'd be lapping me a few times, some people will be running around the other way, but if we all stop at the same spot, that angle we have, those are coterminal angles, they're in the same spot, okay? And it's just about how many laps you made or whatever. We know that what we are looking at when we are measuring them in radians. The reason that you start this in geometry, what they connect it to is arc length, okay? And so the measure of the angle indicated in the figure, it's the arc length divided by the radius. That's how you find the radians. If it is a unit circle, then it is just the arc length. But here's my arc length. And also arc length is just a part of the circumference. You take the arc length, you divide it by the radius, you get the radians, all right? So a radian measure of an angle in standard position is the ratio, again, that's a fraction, of the length of the arc of the circle to the radius, okay? And they give us a little reminder that the circumference is 2 pi r, And we can find the arc length by just considering it. It's just a ratio. It's just a part of the circumference is all it is. It's not that big of a deal. Okay, but that's what radians are about, how we actually find them if we have to find them. Okay, flip this over and let's find some. So theta for radians, that is arc length over the radius. Okay, arc length over radius. We got this little picture here. It says, consider the angle theta created by the quarter circle of radius 4 above. Find the measure of theta in radians. That's the thetian, I guess. So the first thing I need is the circumference. Circumference is 2 pi r, which is 2 times pi. What's the radius? 4. So that gives me 8 pi. That's the entire distance around the entire circle. Do I actually care about the entire circle? No, I want how much of it? A quarter, a fourth of it. So, and I'm looking for arc length. There's not a great abbreviation for it, so we'll just do AL. I mean, it makes sense, right? I just want a fourth of that 8 pi, which gives me 2 pi. Okay. So my arc length right here, this part right here, that is, the length of that is 2 pi. But I want theta, so theta is that arc length, which is 2 pi, over the radius, which is 4, and that just reduces to pi halves. Is that a big surprise that that answer is pi halves? I would hope not, right? Because that, if I rotate 90 degrees, whether it's a unit circle or not, that is still pi halves radians. A fourth of the rotation is pi halves radians. Okay, we good on that? So we're using something we kind of already know to understand how to find it. If you're asked to find anything else, you're either not going to have a picture or it won't be something you already know. I mean, just so that you have an idea of what's happening there. All right, so let's try this one. It says find the measure of the angle formed by a third of a circle with radius 3. And this says a clockwise direction. So what does that tell you about your answer? It's negative. Okay, so we can just plop the negative on at the end. Doesn't change anything else. Circumference is 2 times pi times the radius, which is 3. So that gives me 6 pi. That's the full distance around the circle. I want the arc length. I only want a third of it. So I want a third of that 6 pi. And once again, I get 2 pi. You will not get 2 pi every time. That's just what happened here. Okay. Then theta is going to be, it's clockwise, so I know it's negative. I can stick my negative on there now. The arc length, which is 2 pi, divided by the radius, which is 3. And I got a negative 2 pi thirds. Any questions about where anything came from? We good? All right. So now we're moving on to the unit circle. Imagine if this was the first time you ever heard of it. Things would be very difficult moving forward. We do know that the unit circle is a circle centered at the origin with a radius of 1. Okay, we've got all these special values that we have to know. And then it says the concept of the unit circle will become pivotal throughout the rest of this course. I cannot stress that to you enough. If you do not know your unit circle values, you are going to struggle and be frustrated for the rest of the year. You have to know them, right? I sent out that link for the full unit circle review in a parent square message. It's also in Canvas. But I also figured out the reason I had a hard time assigning it to y'all last week was because the district doesn't support Google Classroom anymore, and that's how I dumped my rosters in there. So I think at least a couple of people tried to access the older ones that I had given you, and I didn't realize you couldn't access them anymore because it's probably not letting you sign in the same way. So I'm going to redo those other ones where it was like just the first quadrant or just what quadrant is this angle. And if you need to practice, I'll redo those and put those out in links so you can still get to them. But use that in practice as much as often as you want. Go back and do it again. Even if you make 100, you've got to know those values. And I wasn't at the door like I said I was going to because I wanted to start the warm-ups and I knew we were going to run out of time anyway. So I may or may not be at the door tomorrow. We'll see. All right, flip this over. Or go to the next page. I'm sorry. Or you can flip it over and go to the next page. This is going on page 84. It says, for each of the following, sketch a picture of the arc length described based on a unit circle. Then find the measure of the angle corresponding to the given arc length. All right, so a sixth of the circle. Well, we know that this would be a fourth. Is a sixth more or less than a fourth? Less. Okay, so we'll just say it's about right there. Like we don't know for sure, and that's okay. And we're going in a counterclockwise direction. That means my answer is positive. Okay. And since we are talking about the unit circle, the circumference of a unit circle is 2 pi because it takes 2 pi radians to get around that. But I don't want all of it. I only want 1/6 of that 2 pi. So that gives me 2 pi sixths, which is pi thirds. And my picture's off a little bit. My picture kind of looks like pi fourths, but it's fine. All right, 2 full revolutions in the clockwise direction. That means my answer will be negative. All right, so I start here. I'm gonna go around the other way. That's 1 revolution, 2 revolutions. So there's my picture there, right? And then I know my answer is negative. And if I go around twice, that's how much? 4 pi. So it's negative 4 pi. Everybody okay with that? Yes? All right. Then 3/4 of a circle and a counterclockwise, so that means we'll be positive again. 3/4 gets me here. I'm not even going to do any math. You should know what that angle is. What is it? 3 pi halves, exactly. All right. 7/8 of the circle is most of the circle, so it's over here somewhere. Look at that. And counterclockwise again, so we know it's positive. So theta will be 7/8 of 2 pi. So what's that going to be? 7 pi fourths. Okay. Any questions about those? All right, so now down here, you have a beautiful little unit circle with all these little lines. Those are your fraction bars for your angle measures if you need them. And I want you to take the rest of this time. We're going to do the back tomorrow. So once you get all your angles filled in on this circle, then you can put this away for today and we will start here tomorrow. Okay, but fill them in.